My name is Kari Bliss. I lead sustainability for PADNUS, and it is truly an honor to be able to chair this session. We've got some great speakers coming up here. So why are we here? This is a picture of ASR. ASR is auto shredder residue. And from our best calculations, of course, the number of cars that enter end of life changes a little bit year to year. But we feel that pretty accurately about 10 billion pounds of this material is ending up in landfills just in the US alone every single year. And I had the fun experience of having lunch with our interns a number of years ago, and I had no idea that this much material from our own operations, and it's not just us, making this pile, this is every shredder around the US. I didn't realize just how much of that material was ending up in the landfill, and I happened to be part of our plastics team at the time, and when I was having lunch with these interns, they said, hey, what about that pile? Why can't we do anything with that? And this was quite a while ago, but I went out there with them, and I looked at the pile, and I'm like, oh, that looks like a really good piece of TPO, and that looks like a really nice piece of polypropylene, and I bet we could actually figure out something to do with that. And it started me on this journey of really wanting to understand, not just from a circular economy and a sustainability perspective, but how can we truly make the best use of all resources across the board. A little bit about PADNUS. We have been around a while. We were founded in 1905. We are very proud to still be a privately held, family-owned business, locally based in Michigan. Our headquarters is in Holland. But we do have 30 locations throughout the state and one in northern Indiana. Since 1905, we've been doing trading of all sorts of recycled content, but specifically around 2008 is when we started diving into the plastics realm. I came to the company a little bit after that, and the rest is history. We end up all the way to where we are today. We recycled about 4.7 billion pounds of material last year, just to give you a little bit idea of scope. Now, a significant portion of that is in the metals realm, but we do a fair amount of paper, plastic, and electronics as well. We are R2 certified, RIO certified to be able to confidentially destroy any type of electronic type materials that we receive. So I thought I would show a little video here because a lot of people have never seen an auto shredder. They don't know what that looks like. So I thought it would be fun to give you a feel for what that's all about. So that's just a little bit about what we do on the metals side of our business. And why is that important? If so much of the work that we're doing today, especially around LCA, life cycle assessment, is all about all the carbon that goes into the product on the front end, everything, because let's face it, once that car is built, it leaves the facility, the OEM, and who knows what happens to it. I mean, it's kind of like how on earth do you track what happens at the end of life to that vehicle that might last 5 years if it gets in a wreck? It might last 10 years, 15 years, 20 years if someone takes really good care of it. So it's hard to understand what happens at the end of life, but that doesn't mean that it isn't a really important part of the equation. So almost any material, I can come up with a way to recycle it, but can we do it in an economic, viable way? When we look at steel's life cycle, it has been circular forever, before the term circularity even got coined. And when cars were mostly metal, they might have been heavy and they may not have been able to make all the CAFE standards, and it might be a problem when we're talking about even heavier vehicles with the EV, but it still was actually able to be recycled, and that was important because we have the technology already in place to be able to recover those metals. And 98% of it is a pretty good ratio. It's certainly a lot better than what you're seeing at what you do at home, curbside. So we're talking a lot about how could disassembly work? Is it even possible? What parts would be disassembled? What good would it do? It might be one thing to remove the fascias or the bumpers, maybe door panels, seat backs. There's a few things that I can logically see doing some disassembly on can work. We can get some resin families at least then together. But most of you in this room realize there is 100 different plastics in a vehicle. And some of them are very problematic for the recycling industry because there isn't just an easy way to be able to sort this material from that material. And if the quantity of the material doesn't add up to much, like take acetol as a lovely example, it's used in such little tiny parts most of the time. what's going to happen to that? And yet we can't just process that the way we would process other materials because of the off-gassing concerns and different ways that that material would have to be processed. So when we're looking at circular economy in terms of plastic, there are some things that we've been able to do. I'm not going to go into too much detail on that because I think you're going to get some great definitions from AdRem's keynote speaking. But there are ways that we can capture some of it, but it's still not 100%. And remember, 10 billion pounds every year is worth doing something about. I like to look back in past sometimes whenever I do one of these talks, because we had a problem with cars being left in our forests, left on the side of the road, left on people's farms. They were everywhere. And we can really thank First Lady, Lady Bird Johnson, for doing a lot of the environmental things that we're familiar with today. I mean, she led to the first Earth Day. She's the one that really helped us figure out how to get these cars recycled. Padnos built our first shredder in 1971, so it's right in the same time period frame. And it worked at the time. Now, do we need to continue to evolve just like all industry? Absolutely. But every time someone puts a sustainable material into their plastic, you are creating a problem for me at the end of life. Things like rims for tires being made out of a highly engineered composite plastic seriously concerns me. Because right now, those aluminum rims, 100% gets recycled. And what am I gonna do now that I've got like maybe 3, 4, 5 different types of material that are highly engineered? Yeah, in theory, maybe I could recycle them, but there is no infrastructure in place today to collect and aggregate that material and make sure that it really gets recycled at the end of life. So really think about that. It's not just the LCA on the front end. What is gonna happen? Not just what's theoretically possible. What infrastructure truly exists to make sure that material gets recycled? We're gonna end up back here. And I get cars look different than this today, but the same thing will happen. We are a for-profit business, and I don't apologize for that. This is, we need to be able to recycle. We want to recycle. And we're willing to expand our mind. We've, built a whole plastics division. But at the end of the day, there still has to be a viable way to recycle those materials. I think Matt did a fabulous job on speaking about some of these regulations, so I'll just highlight here, this is another area that I have to read and study on a regular basis. It is confusing. I'm lucky to have friends like Matt Rolling who can help keep me up to speed because I can't do it all on my own. But these things are impacting our whole industry. It is important to be intentional. We have to come to the table. I'm so proud of so many of the OEMs are coming to us and working with us, meeting our engineers with their engineers and trying to solve some of these problems. And we can absolutely do this together. So what's next? You've got a great keynotes coming up, and then we'll have a networking break. And from there, I'm sure everyone is going to have an enjoyable afternoon. So with that, would you like to come on up?